Next, we're going to learn how to solve systems by substitution. Substitution is when you replace something with what it is equal to. So think about when one of your teachers is gone, you have a substitute fill in for them. They're both licensed teachers, so they're equal in that respect. One of them fills in or substitutes while your regular teacher is out for the day. We're going to be doing something similar with our equations. In the right-hand column, I've got some steps for you to follow when solving by substitution. What you need to be careful of is that you don't mix up which variable you're replacing. So you start by finding the variable that's already alone. Y is already solved for in our second equation. We have y equals, put a box around that value that y is equal to. Then move up to the first equation. We know what y equals, so we're replacing y. So put a box around y in the first equation. And then we're going to put this 3x expression in for y in the first equation because 3x is equal to y. So we're replacing y with a value that it's equal to. Rewriting that first equation, we get x plus, use parentheses for that box. Sometimes we'll need to use distributive property after we substitute. Even if you don't, it's a good idea to get in that habit of using parentheses, because if you've got distributive property and you drop the parentheses, you're going to end up with the wrong equation. One way to check to see that you did your substitution correctly is to look at your equation. We can solve one equation with one variable. If you have one equation with two variables, you did your substitution wrong. You replaced the wrong variable. So go back and start over. We have one variable, so we're going to combine our like terms. X plus 3x gives us a total of 4x. Dividing both sides by 4, we get x equals 2. This is only half our solution because we have two variables. So we'll have to go back and solve for y. I'm going to use the second equation to solve for y because y is already alone in that second equation. I'm going to substitute 2 for x. 3 times 2 gives me a y value of 6. So my solution to this system, we're going to write that as an ordered pair to make that connection between the solution of our system and the lines that these are when we graph them. So the ordered pair 2, 6 is that point where both of these lines would meet on a coordinate plane. To check your solution, you only have to check it in the equation that you did not use to solve for the second variable. Replacing x with 2 and y with 6, I get 2 plus 6 equals 8, so my solution checks out. Next example, same process. This time I have x alone in my second equation, so I'm going to box what x equals, and in the first equation I will only put x in the box. X has a coefficient. We are not replacing the 2. 2 is not a variable. We're replacing x, and then I'll use my parentheses, I'll need distributive property on this one, with y plus 3, because x equals y plus 3. Finishing that first equation, plus 2y equals 38. Checking to make sure my substitution looks good, I have one equation with one variable. I just have y in this equation, so it looks good. I'm going to use my distributive property. Combining my like terms, 2y plus 2y gives me a total of 4y. Subtracting 6 from both sides. And dividing both sides by 4, we get y equals 8. Going to that second equation that already has x solved for, and replacing y with 8. 8 plus 3 gives me an x value of 11. My solution, x value goes first, 11, 8 is the ordered pair where these lines would meet on a coordinate plane. Checking my solution in that first equation, I will replace x with 11. I will replace y with 8 and check to make sure that it totals 38. 2 times 11 is 22, 2 times 8 is 16, and 22 plus 16 is 38, so my solution checks out again. And finally, everybody's favorite, we've got another word problem. Don't let the amount of words on this page scare you. Just dig through. Obviously, the numbers should catch your eye, and you want to read the question because the question will help us define the variables. The question tells us that information that we're looking for. How many laps? So I'm going to let L equal number of laps would he need to complete for his workout to be the same at either pool. Well, what's his workout? His workout is the total length that he's swimming. So I'm going to say W equals the length of the swim. W for workout because I can't use L again for length. We'll call it length of the workout. All right, let's go back and see if we can figure out these two different equations that we'll need to write to determine the number of laps and the length of his workout. At the first pool, he can do a 24-meter warm-up, then laps in a 36-meter lane. So his total workout will equal the length of his warm-up plus 36 times the number of laps that he takes in that pool. The second pool has an option of a 56-meter warm-up, then laps in a 34-meter lane. So his second workout would be a 56-meter warm-up plus 34 times the number of laps. Both of these equations are solved for W, so we get to choose which one we want to substitute. I'll just use that first one, W equals, and we're replacing W in the second equation with 24 plus 36L. So that will equal 56 plus 34L. To solve, we want to get our like terms together. This time they're on the wrong side of the equal sign from each other, so I'll subtract that 34L from both sides, leaving us with 24 plus 2L equals 56. Subtracting that 24 from both sides, we get 2L equals 32. Dividing both sides by 2, we get the number of laps in each pool would need to be 16 in order for them to be the same workout. Using either equation, I'm going to use my blue one since that's the one we started with. The workout will equal his 24-meter warm-up plus 36 meters times the 16 laps that he will take in the pool. So his total workout will be 600 meters. Checking our solution in that second equation, 600 equals a 56-meter warm-up plus 34 meters times 16 laps. 600 equals 600, so that one checks out as well. 2 U-Try questions. The first one, solve by substitution. Practice that skill of solving. For the second one, practice setting up the system. If you feel really confident you've got the right system, go ahead and practice solving it. If you're not so confident, bring your system to class and we'll make sure we're all on the same page before we solve.